All right, in this video, we're going to talk about rational equations. And the big difference here from the last topic, which was rational expressions, equations are equations. They have both two sides. There's an equal sign between them. If you recall, expressions are just, if I just looked at that part, that's an expression. It doesn't equal anything, right? So because these are equations, one way we could solve it is we could combine these two fractions and with a common denominator and then get a single fraction there and do something uh, with that. But the best way, the most efficient way to solve a rational equation like this is to get rid of the denominators. And it's kind of related to how we would have combined these fractions if we wanted to. Notice that my lowest common denominator 2x and 5 would just be all of those multiplied together, 2 times x times 5, which would be 10x. But instead of multiplying top and bottom to try to get a common denominator, the simplest way to solve an equation is to multiply both sides by the lowest common denominator. So this isn't top and bottom. This is just, I'm literally multiplying by 10x, and you can think of this as 10x over 1. Why can I do that? Whatever I do to one side of the equation, as long as I do the same thing on the other side, it's fair, it's valid. And then I'm going to distribute this. And so notice if I distribute this, I'm going to have 10x over 2, and x time is straight across, so that would be 30x over x. And here this would be 40x over 5. And notice if I reduce this, I don't have any more denominators. This is just 5x plus 30 equals 8x. Subtract the 5x to the right side, I have 30 is equal to 3x. And if I divide by 3, I get x is equal to 10. One thing we might as well start with this problem to kind of pay attention to is whether our answer makes sense. Now, of course, one thing you could do, you can check your answer by plugging x equals 10 and making sure that 1/2 plus 3/10 equals 4/5. And that's fine. If you have time and energy to do that, that would be good. But at the very least, what you should be considering when you have a rational equation like this is whether this answer is allowable. Here's what I mean by that. If this answer was 0, then this term would be 3 over 0, and we've talked about that. That is undefined. Sometimes we refer to that as a restricted value. So we could say x equals 0 is a quote-unquote restricted answer, I guess. Answer. So if we had gotten x equals 0, we would have said, oh, sorry, that's not an answer that works. There would be no solution to the problem. But because our answer is not 0, then we're just going to trust ourselves that we did our math right, and x equals 10, in fact, is the correct answer. But you should be thinking about what the restricted values are, the restricted answers. So for example, on number 2, I might as well acknowledge that right off the bat. For both of these fractions, if x was 0, I would have issues. So I would just make a note here to myself, and I would say x cannot be 0. And we'll see what happens when we solve this. If we end up getting x equals 0, then we'll have to rule that answer out. My lowest common denominator for 1, you can think of 1 as 1 over 1. 1x and x squared would just be x squared, because x goes into x squared and obviously 1 does. So for this one, I'm going to multiply both sides by x squared over 1, if that helps. Distribute in, I get x squared minus 8x squared over x equals 15x squared over x squared. You can reduce this down to x squared. I can cancel one of these x's, minus 8x equals 15. Okay, now we have to have the wherewithal to know that if I've got x squared minus 8x equals 15, if I move that 15 over, then this is equal to 0. And we can solve this by factoring, something else we've been doing recently. So this factors two numbers that multiply to negative 15 and add to negative 8 would be negative 5 and positive 3. And then to get our answers, this is what we call the zero product property. Zero product property. And what that basically says, if you think about, remember what x means at its core. X is hiding some number. We're looking for what numbers we could plug in here and have this term times this term equals 0. So if you think about it, if I told you I had two numbers equal to 0, think of a product of two things that equals 0. Well, 7 times 0 is equal to 0. 0 times 5 is equal to 0. 0 times 0 is equal to 0. So whenever we have two numbers equal to 0, what it means is one of these two numbers, or maybe both, equals 0. And so what we do is we say, okay, this means either x minus 5 is equal to 0 or x plus 3 is equal to 0. In other words, x equals 5 or x equals negative 3. And it's fine to just condense this down to say x is equal to 5 comma negative 3. And then we just double check, is that an allowable answer? Well, neither of those answers was 0. So those would be our two answers. Okay. Now this only works when you set these equal to 0. For example, if you had something equal to 6, for example, two things multiplied to equal 6, there's lots of options, right? You could have 1 times 6 is equal to 6, 2 times 3 is equal to 6. You could have 12 times 1/2 is equal to 6, right? There's too many options. But whenever you have a product of two numbers that equal 0, one of them at least needs to be equal to 0. That's why this works. So this is only useful when the right side's equal to 0, which is a good strategy then when you're solving equations, especially if you have something a degree of 2 or higher, you're going to want to move everybody over to one side and set your equation equal to 0. All right, next example here, 1 over x plus 2 plus x over x plus 4 equals x plus 7 over x squared plus 6x plus 8. Now, our strategy now is not to try to combine fractions with a common denominator. We want to try to get rid of our denominators. So we need a lowest common denominator. And what you're going to want to do if you see something like this is first factor it. So both of these are individual factors, but x squared plus 6x plus 8 factors into two numbers that multiply to positive 8, add to 6, plus 2 plus 4. So then to get rid of the denominators, the lowest common denominator of the entire problem would just be this, because that's in there and this is in there. So to get rid of the denominators, I'm going to multiply both sides by the lowest common denominator, x plus 2 times x plus 4. Again, this is in the numerator, that's over 1. Okay, now to save a little time here, when you multiply this in here, it's going to go right up there, and you'll notice you're going to have an x plus 2 over an x plus 2. So the x plus 2 is going to cancel, and we're just going to have x plus 4. Similarly, when I multiply this in here, you're going to have an x plus 4 up here. There's an x plus 4 down there. So these are going to cancel. So we're just going to be left with x times x plus 2. Now on the right side, if I distribute this in, that cancels with this, and the x plus 4 cancels with this. So I'm just going to be left with x plus 7. Ooh, I forgot to do my restricted values. What would be my restricted values in this original problem now that we see all the denominators? What would make this denominator 0 is negative 2. This one would be negative 4. So we'll just take note that x can absolutely not be equal to negative 2 or negative 4. Okay, let's proceed here then. If I distribute this, whoops, plus. This is x squared plus 2x. And the minute I see that x squared, kind of like the last problem, I'm thinking this might be a quadratic that I can factor. So I want to move everybody over to one side and set this equal to 0. I mean, the fast way to do this, if we subtract x here, subtract x there, we get that x to cancel with that x. And if I subtract 7 from this one, then I'm going to have, I'll put these two first, x squared plus 2x, 4 minus 7 is minus 3, and this is equal to 0. This factors, multiplies to negative 3, adds to 2, that would be positive 3 minus 1. And that 0 product property, then to get two answers, I'm going to set this one equal to 0, or x minus 1 is equal to 0. This gives me negative 3, or x is equal to positive 1. And both of those are allowed values, so those would be our two answers. Okay. Next example, restricted value. 3 is just over 1, so it's the same denominator on both of those. And what would make that denominator 0 is negative 4. X cannot be negative 4. Get rid of the denominators. We'll just multiply both sides by x plus 4 over 1. Here, you have 1 here and 1 here. That's going to cancel out, so we're just going to have x. If I distribute in here, I'll have 3 times x plus 4. And then for this term here, the x plus 4s will cancel, so that'll be minus 4. Distribute the 3. If I subtract 3x over here, I'm going to have negative 2x. 12 minus 4 is equal to 8. Divide by negative 2, x is equal to negative 4. Okay, you can see why this is kind of important, because if you weren't paying attention, you would think that's the answer. But notice that that is the one answer that x could not be, or my function would be undefined if x was negative 4. So because x can't be negative 4, we just have to say there is no solution to this one. That was the only answer that came out algebraically, and it was not going to work. So no solution. And the way it works, if x can't be negative 4 on a different one, and you end up getting 2 possible answers for x, you just rule that out and the other answer works. So it doesn't always mean there's no solution. But if that's the only answer you get, and that's the only answer that x can't be, then obviously that would be no solution. Okay, maybe a good time to pause the video and try this one on your own. Okay, hopefully you did that. The denominator is already factored, and this is just over 1, so my lowest common denominator is just going to be the product of those two. That's what I'm going to multiply both sides by. Let's use blue for this. So I'm going to multiply both sides by 2x plus 7 times x plus 3 over 1. Oh, can't squeeze that in here. 2x plus 7 times x plus 3 over 1. So distributing in here, I get a 2x plus 7 to cancel. There's one in the top, one in the bottom, so I'm going to have x times x plus 3. Minus, if I distribute that into here, this time my x plus 3's divide out, and I'm going to have 2x plus 7 times x plus 1. And on the right side, it's just this times 1, so that's what it is, 2x plus 7 times x plus 3. Okay, we should distribute To be safe, one thing I do when there's a negative, but I know I have to multiply this out, this negative is applying to this whole product. So what I'm going to do, just going to kind of emphasize here, you've seen me do this before where I just use brackets. I'm going to first multiply out, FOIL out these two binomials, and then I'll apply the negative. So 2x times x is 2x squared. That's positive 2x plus 7x. 7 times 1 is plus 7. And here I got to FOIL this out. 2x squared plus 6x plus 7x. 7 times 3 is 21. This is x squared plus 3x. Now I'll distribute the negative to everybody. Minus 2x squared minus 2x minus 7x minus 7. You might as well combine like terms over on this side. And let's combine like terms over here. So I have an x squared and a negative 2x squared. That's negative x squared. 3x minus 2x is 1x. Minus another 7x is minus 6x. And now since I see I have some x squared terms, I want to make one side equal to 0. It doesn't matter which side. I would say it's probably easier, since all of these are negative, to just add these over to the other side rather than move these over here and make them more negative. So I'm going to add x squared, add 6x, add 7. So the left side is 0. This gives me 3x squared plus 19x plus 28. And then we just hope this factors. As some of you know, if it doesn't factor, there is a quadratic formula, which we will be talking about later, that we could use to solve this quadratic. But I always say give factoring an honest try, because the quadratic formula, if you know it, would not be pleasant with these ugly numbers, 19 and 28. So in my head, I'm thinking, okay, factors of 28, there's 1 and 28, there's 2 and 14, there's 4 and 7. And if you try the 4 and the 7, yeah, if I put the 4 there and the 7 there, then I'm going to get a 12x and a 7x, which adds up to 19. So I'll make these both positive. And then zero product properties. So I set 3x plus 7 equal to 0, or x plus 4 equal to 0. Subtract the 7, divide by 3. So one answer is negative 7/3, or x equals negative 4. Ooh, what did I forget to do? Is that allowed? Right? My restricted values, I forgot to do that at the beginning. And that's okay. You just, as long as you're aware of it at some point. If I set that equal to 0, I'm going to get negative 7/2. So x can definitely not be negative 7/2. Set that equal to 0, that would be negative 3. It was close, but neither of my answers equal those. So these would be my two answers. Okay, one final thing. Sometimes with irrational equations, you might approach them differently. What's different about this one than most of the problems we did is a lot of them had like two terms here and then one term there. You can go back and look. But basically, this is an equation where it's basically just a fraction equals a fraction. And that's referred to as a proportion. And what you could absolutely do is you could multiply both sides just like we were doing before. You can multiply both sides by the lowest common denominator, which is x minus 2 times x plus 4. But with a proportion, sometimes maybe a faster way to do it, we take advantage of this, that if you have two fractions that are equal to each other, for example, say I have 2/3, which I know is equal to 4/6, because 4/6 reduces to 2/3. The reason that's true is because we call this cross multiplying. 2 times 6 is the same as 4 times 3, that they're equal to each other. And that's always true. Whenever you have two fractions equal to each other, here, let's do another one. What about 1/5 and 2/10? If I cross multiply, 2 times 5 is 10, 1 times 10 is 10. So what is always true when you have a proportion is the cross products are always equal to each other. So I know right now that x plus 1 times x plus 4 better be equal to x minus 3 times x minus 2. And by doing that, what do you notice? I don't have any denominators anymore, right? And then if I distribute this out, now that you've been doing some algebra and multiplying polynomials together, you may picked up on something that can save a little bit of time, is when you have a binomial times a binomial, when I do, the first term is going to be x squared, but the two terms next will combine. They're like terms. I'm going to have a 4x and a 1x, which together gives me 5x. And if you can do that in your head, it's going to make your algebra go a little bit faster. And then I have the 1 times the 4, which is 4. Over here, x squared. So that's minus 2x, that's minus 3x. Those would combine to minus 5x. And then negative 3 times negative 2 is plus 6. Let's see. Notice, doesn't matter which side we put it on, but if I subtract x squared, that's going to cancel on both sides. So I'll add 5x plus 5x. So I have 10x plus 4 is equal to 6. Subtract the 4 over. And then divide by 10. So I get x is equal to 2/10, otherwise known as 1/5, which was one of the examples I used for my proportion. Oh, and once again, what did I forget to do is to make sure that is this an allowable answer? Looking at the original problem in the denominators, my restricted values would be positive 2 for this one and negative 4. And since 1/5 is not any of those numbers, then that would be our answer. All right, so hopefully this is helpful. Let me know if you have any questions, and if you spotted any mistakes I might have made. I appreciate those. You tell me that. All right, thank you.